Welcome to some clarifying thoughts on the circle of confusion. My name is Timothy Lattice, and this is the Neo-Kino Graphics channel. Today I'm going to make a case for an alternative depth of field model. Let's start with some truths about the circle of confusion. Far radius converges to some maximum limit at depth equals infinity. This part is very easy to handle. However, the near radius goes to infinity at depth equals 0. Thus, near field behavior is impossible to render correctly. And note, one can also see through stuff in various cases. I'd rather have a model that is modified for render limits. For example, specify a near plane. Nothing gets rendered in front of the near plane. Specify a radius at depth equals infinity. Specify a max radius at depth equals near, i.e. the near plane. Do the minimum modifications to the real model in order to fit those above constraints. And note, the modifications must maintain the standard real circle of confusion curve shape too. Here's an example of a render limit adopted model. Note, in this case, x is equal to depth, or z. D is the near max radius. This is shown with a dotted red line. I is the far max radius. This is shown with a dotted orange line. F is the focal distance. The real circle of confusion is the black line, or the black curve. The near plane is n. That's represented by the dotted blue line. The adapted circle of confusion is the green curve. You'll notice that there is only one extra add required in the computation for the adapted circle of confusion. And that extra constant is at the bottom. That's k. Also note, the shape is maintained, but is basically stretched to fit whatever practical render limit. Also note that there's this max 0 part in the constant. That ensures that when it is possible to do the real world, the adapted one equals the real one. And that's it for today. Hopefully somebody finds this useful.